Okay, hey guys, this is the first flipped lesson that you're doing. So basically, you're going to watch this lecture at home and then you're going to come back to school ready to practice. I'm having you watch this at home so you can kind of learn about this stuff without distractions, and then that gives us extra in-class time to practice and make sure you really have it down. This is going to lay a really good foundation for next year and the year after, and then any sciences after that. So really important stuff. It is a bit tricky, but we'll do it together. And like I said, we'll practice a whole lot in class. So there are three types of bonds. There's ionic, there's covalent, and there is metallic. Metallic's not a lot to know about that. We'll talk about that later. And covalent we'll talk about the next. So ionic bonding. Ionic bonding is between a metal and a nonmetal. And it happens because, and this is nothing new, you already know all of this information. Every element is trying to achieve a stable electron configuration. And a stable electron configuration is 8. So if you just remember, 8 is great, and that's the octet rule. So remember 8, okay? And if we were to do a Lewis dot diagram of neon, sorry, my drawing is not the best, but you'll get the picture. If we were to do a Lewis dot diagram of neon, it would be 8 dots around it. And neon has that stable electron configuration, and every other element is trying to get that. So, second, and if you want to go ahead and pause the video, and I want you to try to practice doing your Lewis dot diagrams because you really need to understand these to understand ionic bonding. Okay, so here is what you should have for ionic bonding, I'm sorry, Lewis dot diagram. So, and this is totally a review. So everything in group 1A, I'm going to change my pen color, has one valence electron. Okay, so that's why it has one dot. 2A has two valence electrons. And then remember, we skip the transition metals. That's these in here. Anytime if I give you a transition metal to do an ionic bond with, I will give you its charge. So for instance, if I said Fe and I put a Roman numeral in here, that would mean that iron has a charge of, or has two valence electrons. And we'll talk about that later. But that just gives you an idea. So if I ever give you a transition metal, I will tell you what they are. Okay. So, and then you go on through the periodic table, and then here's everything in group 8A. These are the ones that are stable. They are happy. They have what all the other elements are trying to achieve. And then just remember, helium only has 2 electrons, so therefore it only has 2 to be full and happy. So it kind of doesn't follow the octet rule, but it's still stable because it's full on that first ring. So this is step 1 to understanding ionic bonds, is understanding how many valence electrons they have and how many they need to get to a full shell. So if you look, everything over here, for instance, group 7A, these are really close to having a full shell. That's why they're really reactive. They only need one more electron to get to 8. These guys in group 6A only need 2 more electrons to get to 8. Now, these would only need 3 more electrons to get to 8. And then these could go either way. These could gain 4 electrons or they could lose 4 electrons. So all of these elements, these are really far from getting to 8. So what they're going to do is they're actually going to give up their electron and drop down to the lower energy level. And we'll talk a little bit more about that in a little bit. So like I said earlier, noble gases are stable. They have 8 valence electrons. They're totally full. All right, take a second and watch this video clip. You can pause this movie and you should be able to click right on this guy in the bottom corner and watch this video. It's super short, but it's going to talk to you a little bit about ionic bonds. Okay, so here's where we're headed. This is an ionic compound. This is table salt. This is sodium chloride, NaCl. And what happens is, this is what we're talking about. So all we have, don't get overwhelmed by this, all we have are the Lewis diagrams. So for instance, I might say, what bond would form between sodium and chloride or chlorine? And you would start with sodium. and draw a Lewis dot diagram of that, just like you have here. Oops, I didn't mean to add another dot. Then have chlorine, and you'd do, your Lewis dot diagram of chlorine. Chlorine has 7 valence electrons, okay? And here's what happens and this is everything we talked about Tuesday. So sodium gives up its electron to chlorine. It says, here you go. And when sodium gives up an electron, it now has one less electron than it does protons. So it ends up with a positive charge. Chlorine gains one extra electron, and now it has a negative charge. And as we all know, positive and negative attract. Okay, so that's an ionic bond, is you have a metal over here and a nonmetal over here. The metal gives an electron or more to the nonmetal, and they are attracted because of their opposite charges. That's all. That's an ionic compound. Everything in group 3 will have a charge of +3 because they will give up 3 valence electrons, and they'll have 3 more protons than they do electrons. Now, this group is weird. I won't trick you and pick one of these groups, but notice that these have 4 valence electrons. So 4 is right in the middle of 0 and 8. So what happens is they could go either way. They typically are going to, and you've also got metals and nonmetals. They're typically going to gain 4 electrons and not give up. But the metals could, of course, give up 4 electrons. But don't worry, I won't trick you with one of those. Okay, now everything on this side of the periodic table, these are all nonmetals, and they are closer to getting to 8. So they are going to take electrons to get to 8. So everything in this group is going to have a charge of -3, and everything in this group is going to have a charge of -2, and everything in this group is going to have a charge of -1. And then remember, these guys are stable and happy because they meet that octet rule, okay? So these would gain 3 electrons, giving them -3. These would gain 2 electrons, giving them -2, and this would gain 1 electron, giving it -1. And if you do the math, basically, if these all have 5 electrons and they gain 3 more, they get 8. If these all have 6 electrons, because they're in group 6A, oxygen's family right here, and they gain 2 more, that brings them to 8. Everything in fluorine's family has 7 electrons, valence electrons, and if they gain 1 more, that gets them to 8. Like I said, I know this is a lot. That's why you're listening to it at home, so you have some background understanding, and then all of our time in class is now freed for us to practice this together. I think having a lot of practice, it's actually really easy once you practice it. And here's what we have. This is the periodic table of ions. So if you see, everything in this group is going to get a charge of +1. Everything in this group is going to get a charge of +2. These depend. So notice they have Roman numerals. Like this has Roman numeral 4 right here. And that's why it has a charge of +4. So I will always give you a Roman numeral for those. Everything in this group is going to get a charge of +3 because they're going to give up 3 electrons. Remember, I told you that these in group 14, these could go either way. So if you look at those, you can see those charges. And then over here's our nonmetals. So all of these are going to gain electrons from here over. So these all have a charge of -3, these all have a charge of -2, and these all have a charge of -1. And this is just one of those things that I'm going to expect you to know on the test. I might say, what ion does fluorine form? And it would be -1. Notice these endings are a little bit different. We will talk about that over after Christmas, but it's still the same element. The ending just changes when you put it in a name. All of these fun things up here, these are called polyatomic ions. Poly means many, and we know an ion is just a charged particle. So these things act the same way as everything else on the periodic table. It's just a group of elements. It's a group of them. And I'm not sure when you're watching this video, but at some point I'm giving you a table of common polyatomic ions. Don't worry, I do not expect you to know these. And if I ask you about one of these on the test, I will absolutely give you the formula so you won't have to memorize those. All you have to understand is the charges that each of these ions will form. Okay? So what happens for an ionic bond is you have a metal over on this side forming a bond with a nonmetal over on this side. The metals give up their electrons and the nonmetals take electrons. So this is just more examples of ions. Now, a cation is just a positive ion. If you're not a cat person, I apologize. I like cats and dogs, but I try to think of it as I like cats, so cats are a positive. So a cation is positive, and this is one of those terms I'm going to expect you to know. An anion is negative, okay? If you think of the word anti or against or anything like that, I think of that as like negative, okay? So an anion is negative and a cation, this is a happy cat, is positive, okay? So everything on the left side of the periodic table, the metals, are going to form cations. It's really hard to write with a mouse, and I apologize. Everything on the right side of the periodic table, the nonmetals, these are the ones that are gaining electrons. So these are the anions, okay? And all we're doing is we're giving a name to these types of ions. Don't worry about the naming stuff, about this chloride ion and all that. We're going to talk about that more after the break. That's a little bit much before Christmas. A little bit more about ions once again. This is just more review. So for instance, sodium is in group 1A. So I'll draw a Lewis dot diagram of sodium. Sodium has one valence electron, okay? It's easier for sodium to give up an electron and drop down to that lower energy level, and that's when it gives up an electron, then it still has 11 protons, but because it's given up an electron, it now has only 10 electrons. This is kind of like math. If I were to say 11 plus negative 10, well, I would get positive 1. So that's why sodium forms an ion of Na plus 1. Whenever we write an ion, we always write it, it looks like an exponent, so we write it up high like that. That's called a superscript. Or you could write it, notice they didn't put a plus 1, they just put a plus, but it's the same as saying plus 1. It's like having X and 1X. If I said X and I had 1X. They mean the same thing. It's like there's an invisible 1 there, okay? So you could write plus or you could write plus 1. It means the same thing. So we now know how ions form, and like I said, we spent all day on Tuesday working on this. And if you're confused, remember you can come to me. We're going to do lots of practice with ions. But once the ions have formed, they have opposite charges, and those opposite charges attract them. And that is the chemical bond, is that force of attraction that holds them together as a unit. And that's an ionic bond. It's the force between the cations and the anions together, okay? And then, of course, electrons are transferred. And that's unique to ionic bonds, the electrons being transferred. So if you put it all together, we looked at this earlier. So just to recap, sodium gives up its one electron and it becomes positive, okay, because it has one more proton than it does electrons. Chlorine gains that other electron that sodium gave up, and it becomes negative because it has an extra electron. And then these two are attracted to each other because they have opposite charges, and all this forms is sodium chloride. We'll talk more about the naming, and that's table salt. Just to go over real quick, one of your vocab terms, all you need to know about this is what it means. Other than that, we're not going to go too much in depth. Just know that that energy that's used to remove, it's energy used to remove an electron is ionization energy. So when that electron, for instance, is removed from sodium, the amount of energy that it took to do that is just called ionization energy. That's pretty much all you need to know for that. And then there's a pattern. I know in our last chapter, not nuclear chemistry, but when we talked about the periodic table in that chapter, we talked about all these patterns on the periodic table. And these are the trends of ionization energy. And if you remember francium down here and cesium, they are highly reactive, the most reactive elements on the periodic table. Well, that makes sense. They have that one electron that they really want to give up. Sorry, this is supposed to be a one I'm not sure what's happening. So they really want to give up that electron, and when they do, they give it away. And that's why their ionization energy is really low, because it doesn't take a lot to get them to react. And then these over here, everything in group 7A, they all have 7 electrons. They don't want to give up an electron. They are so close to getting 8. It would take a lot of energy to remove an electron from something like fluorine over here. Same with these guys. These all have 8 valence electrons. They're super stable. It would take a ton of energy to get rid of their electrons. So they aren't wanting to do that. I'm checking. I believe this is our last slide. I think actually we have away. So, like I said, lots of practice in class. So just stay with it. I promise it's not that hard, and we'll do it together. That's it for this video. Thanks for watching, guys.